Decomposition reactions are also really easy to recognize because these will only have a single reactant. The only thing you can do if there's a reactant, just one reactant, is break it up into multiple pieces. So decomposition reactions will start with one reactant and have multiple products. So these are the easiest to recognize, but they are probably the most difficult to predict. So you are going to be responsible for being able to predict the products of 3 different types of decomposition reactions. The first is the decomposition of a hydrogen carbonate. So this is our polyatomic ion, hydrogen carbonate. When this combines with a metal, it will decompose into always the same 3 things. It will decompose into the metal carbonate, it will carbon dioxide, and water. So the first thing to do is to determine what the metal carbonate is. The metal carbonate means you find the metal, so in this case it's calcium is our metal, and you write that formula with carbonate. Carbonate, remember, is a polyatomic ion as well. It's CO3, 2 minus. Since calcium is a metal, carbonate is nonmetals, then this is an ionic compound, so like always, we need to make sure that this compound is electrically neutral. In this case, calcium is 2 plus, carbonate is 2 minus, so it's already neutral. So calcium carbonate, CaCO3, is the first part, or is our first formula. So the metal hydrogen carbonate will break up into a metal carbonate, calcium carbonate, carbon dioxide, and water. So it'll always break up into carbon dioxide and water, and then the metal carbonate. Then we can go back and balance the equation. So this one, since our hydrogen carbonate over here on the reactant side has broken up, there's no hydrogen carbonate on the product side, we need to treat each element separately. So on the reactant side, we have 1 calcium, we have 2 hydrogens. Because of this 2 here, multiply that number by everything inside the parentheses, so the hydrogen multiplied by 2 is 2 hydrogens. We have 2 carbons, and we have 6 oxygens. On this side of the equation, calcium, we have 1. Hydrogen, we have 2 from the water. Carbon, we have 1 in calcium carbonate and 1 in carbon dioxide, so for a total of 2. And oxygen, we have 3 here, plus 2 is 5, plus 1 more is 6. You can see this equation is already balanced. So that was the first kind of equation, or the first type of decomposition reaction that you'll be responsible for knowing, a metal hydrogen carbonate breaking up. The second type that you'll be responsible for knowing is when you have a metal carbonate breaking up. So here we have a metal, sodium, and a carbonate. When this breaks up, the metal carbonate will always break up into a metal oxide and carbon dioxide. So our metal is sodium, so we'll put sodium. If it's an oxide, that means it's reacted with oxygen. Since sodium is a metal, oxygen is a nonmetal, we have to determine the charges on these to make sure that the compound is electrically neutral. In this case, since oxygen is 2 minus and sodium is 1 plus, we need an extra sodium atom to make sure it's neutral. So sodium oxide looks like this, and then whenever a metal carbonate breaks up, carbon dioxide will be a product. So we have our metal carbonate, in this case sodium carbonate, breaking up into our metal oxide, in this case sodium oxide, and carbon dioxide. And then we can go back and balance the equation. For here we have sodium with 2, carbon with 1, and oxygen with 3. Over here we have sodium with 2, carbon with 1, and oxygen present in both of these with 3. So this equation is also already balanced. Okay, and the last type of decomposition reaction that you'll be responsible for knowing is when a metal oxide breaks up. So here we have a metal, aluminum, and oxygen for a metal oxide. So when this breaks up, it can only break up into two things because we only have two elements present. So it'll break up into the metal and oxygen. Now remember, oxygen is one of those funny ones that always occurs as a diatomic, so it always occurs in groups of 2. So when aluminum oxide breaks up, you have one aluminum metal and O2 for oxygen. Then we need to go back and balance this equation. So we have aluminum over here with 2, oxygen with 3. Over here we have aluminum with 1, and oxygen with 2. We weren't as lucky with this one and already balancing. So when you have an element where one has 2 and one has 3, or one is even and one is odd, the easiest thing to do is switch those. So we'll put the 3 from this oxygen over here, and we'll put the 2 from over here, which gives us 6 oxygen in both cases. But that also changes this aluminum to 4, so we need to put a 4 prefix here, or coefficient here. And then it is balanced. So those are the 3 types of decomposition reactions that you'll be responsible for knowing.